In this video, we are going to look at some more exponential growth and decay. So just a reminder to get us started off here, exponential growth or decay are going to look similar to this, where we have our function is equal to a times b to the x, where this a value here is whatever our starting amount is, and then this b value here is our growth or decay factor. So that b value there is what we're really going to be focusing on to decide if we're exponential growth or decay. So that is our constant ratio, what we're multiplying by over and over. So in order to be growth, we have to be multiplying by something more than 1, right? If you multiply by 2, your number is going to get larger. Multiply by 5, your number is going to get larger. For exponential decay, that b value is between 0 and 1. So if we look at multiplying by something between 0 and 1, think about a fraction. If I multiply by like half, if I take half of something, it's getting smaller, a third, something like that. B is always going to be positive. That's part of what makes it an exponential, is it has to be positive. So let's look at some examples here with our growth and decay. So for each of the following, we're going to identify if it models growth or decay, and then identify the initial amount, the growth or decay factor, and the growth or decay rate. Okay, so that rate here, we're looking at how much are we growing or decaying by. We're going to be thinking what percent, and go back to that 1 plus or minus r to be thinking about that. So if we have this 4 times 0.03 to the x, so again, we're going to be really focusing on what are we taking to that x power, what are we multiplying by over and over. That is going to tell us our growth or decay factor. Our initial amount is always this value here, right? Because if we took that whatever here to the 0, it would just be 1, and we'd be left with whatever that is. So our initial amount here is 4. Our growth or decay factor is 0.3. Since that is between 0 and 1, we're talking about a decay factor. And then for our decay rate, we're thinking back to here. So if we have 0.3 remaining, that means we have 1 minus r gives me that 0.3, which means that that growth or decay rate has to be 70%. Or if you put 0.7 is fine here too. Initial amount for the second one. Again, we're looking at what are we multiplying by? What is our constant ratio that we're multiplying? So our initial amount, we're starting with 7. We have that 1.45, which is a growth because it's more than 1. And our circle here, growth rate then is what did we get more than that 100%. So we added another 45% to my 100%. Okay, hopefully these are getting a little second nature. Might be a great time to pause, try it, and then check your answer. Initial amount, what we're starting with, we have 1,000. Okay, growth or decay factor, we're multiplying by a third each time. Okay, and then since it's decay, that's less than 1. We're thinking, what do I have left? Or I have a third left, which means I took away 2/3 or 66.6 repeating percent. 2/3 is fine there, right? So you're thinking 1 minus your rate equals that 1/3, which means that I have my rate is 2/3. Okay, another one here. So we started with 6. Growth or decay factor is 3. So our growth or decay rate, 1 plus what equals 3. We're actually growing by 200%. So we're getting 200% larger. Okay, most of these, they won't say 200%, we'll say tripled. But that's a growth of 200%. And this is a growth rate because it's more than 1. Okay, let's look at a few more intense examples here. So we're going to look at a half-life. Carbon-11 has a half-life of 4 hours. If you start with 2,000 milligrams of carbon-11, how much is left after 2 days? Okay, so be careful here. These things don't match up. This is hours. This is days. So we're going to have to get those to match up before we put them in. But we're going to say our function f of x equals, what did we start with? 2,000 milligrams. It's a half-life, so we're multiplying by a half to the x, okay? And then keep in mind that x is 4-hour periods. So if I want to figure out what to put in for x, I need to say 2 days is times 24. That's 48 hours. So to figure out how many 4-hour periods, we're going to divide by 4, and we get that it's 12 4-hour periods. So that is what we're going to put in place of x here. And then we can utilize our calculator to actually figure out what that is, because it's going to be a large number. So if I take, the 12 is going to give us a large value there. We could do that, but 2 to the 12th itself is just a large number. So 2,000 times 1/2 to the 12th. Okay, and we shouldn't have very much left, right? Because it's getting half as big each 4-hour period, and we're doing 12 of those 4-hour periods. So 0.49 about milligrams of carbon 11. Okay, so if you think after 4 hours, there's only 1,000. 8 hours, there's 500. After 12 hours, we're down to 250, right? We're having it each time. So having a very small amount left after 12 of those 4-hour periods hopefully makes sense. Okay, let's try some more here. So we're going to shift gears a little bit into a little bit different of an example, and that's compound interest. So you might notice that this looks really similar to our 1 plus r, but we've put in this additional variable here, this n. So this n is what our big change is here, and that has to do with our compounding. We'll talk about that in a minute. So A is the amount after t years. P is our principal, which is your starting amount. And then 1 is that 100% that you're starting off with. You get to start with 100% of whatever you had. R here is your rate, just like we've been doing. And then we are going to look at these other things here. T is the time. Usually that's in years. And N is the number of times per year that we're compounding. Okay, so what this means is that usually when you have an investment, you are putting in a certain amount of money, that's our principal here, for a certain rate. But not always do you just get that rate at the end of the year. Actually, most of the time you don't just get that rate at the end of the year. What they do is they split that rate up into a certain period of time. So annually would be 1 time per year. Semi-annually or biannually would be 2 times a year. Quarterly, 4 times a year. Monthly, 12 times a year. So what they do is they take that rate and they split it up equally into those pieces. And then you're actually getting that interest more times. So getting your interest at the end of the year, you just get your 3% or whatever at the end of the year. Let's make that a better number, 4% at the end of the year. But if it were quarterly, they'd take that 4% and split it up into 4 pieces. So you'd get 1% after the first quarter. But then the second quarter, you get 1% on that percent that you've already earned. So you end up earning a little bit more if it's compounded more frequently than just annually. So let's look at some examples that go along with this. Let's do some color coding here. So we'll take our rate and our principal. Color haven't I used? We'll use orange for the time. Okay, so we have all those different pieces. We're going to put them together to solve these problems. So we have $12,000. So we're already thinking that's what I'm investing. That's my principal. That's what we're starting with. It's invested at a rate of 2%. There's our rate. Remember, it's a percent, so we're really thinking 2% is 0.02. What is the account balance after 3 years? Okay, so here it doesn't tell us when it's compounded, so we're going to assume annually if they don't tell us otherwise. So if I take that $12,000, I'm going to take A equals $12,000. Oh, it's not $12,000, it's 1,200. Put in the right number. 1 plus 0.02 divided by 1 to the 1 times 3. Okay, so we have all those different pieces. It doesn't tell us, so we're going to assume it's annually. Okay, you can just put this directly into your calculator just like that. 1,200, 1 plus 0.02 divided by 1 to the, careful with your exponent here, because if I just put to the 1 times 3, it's going to take this to the first power and then multiply that answer times 3. So make sure you put parentheses there so that it's going to do that whole thing. In this case, you could just put 3. Okay, so your investment is worth $1,273.45. It's money, so make sure you're rounding to the nearest hundredth. 9 bumps that up to 5. Okay, what then if we take this investment and we compound it quarterly instead? So we're still going to have the same exact equation, but we're changing our n to quarterly, which means 4 times per year. So I'm going to have this exact same equation, but we're going to change this. We're going to split that 2% up into 4 equal pieces, and then we are going to get those 4 times more because quarterly. Okay. So we still start with 1,200. 1 plus 0.02, but we're going to split that up into 4 equal pieces. But then we get it 4 times per year, so 4 times 3 times total. Okay, so we're going to have the same thing that we just put into our calculator, 1 plus 0.02, but we're going to split it up into 4 equal pieces. Even more important here that you keep your parentheses there or do that part on your own so that it's actually taking it to the 12th power there. So here our investment after 3 years is worth $12,100. Wow, I really want this to be $12,000. $74.01. Again, rounding to the nearest hundredth. Okay, so you can see that just by changing when it's compounded, we still have the same rate, same amount of time, but we earn a little bit more money, like 56 cents more, just by changing when it's compounded. Okay, so let's take a look at a couple more examples with this. We have a $15,000, this one is $15,000 investment at a rate of 4.8% compounded monthly. We want to know what is the balance after 3 years and how much interest is earned after 3 years. So interest is what you've earned on top of that original principal. So to figure out that interest, we're just going to take your total minus your principal. What did you put in? Okay, so let's break apart these pieces here. We have $15,000. It's invested at a rate of 4.8%. Make sure you make that into a decimal, so 0.048. Compounded monthly, so that's telling us what our N is here. Monthly means 12 times per year. And we want to know what is the balance after 3 years. So we have our principal is 15,000. We get to start off, keep 100% of that principal, plus an additional 4.8%, but we're splitting that 4.8% up into 12 equal payments. And then our exponent is going to be 12 times 3, because we're getting it 12 times per each year. So then from there, we can put that into 15,000. 1 plus 0.048 divided by 12 to the, make sure you have parentheses, 12 times 3, or actually do that, and it's 36. Okay, so we now have $17,318.29. Okay, which means if we want to know how much interest earned, I'm just going to do that number, $17,318.29 minus that 15,000 that we started with initially. And subtract 15,000. And we get that we earned $2,318.29 on that principal that we invested. So pretty good investment there, right? 4.8 is a good investment rate if you get the opportunity to invest in that. So a little bit more with compound interest. Make sure that you're really paying attention to that growth or decay rate and what that means in terms of your problem. Thank you so much for watching.